Hello everyone and welcome to our Instagram live event. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of our educational event today is deduction, induction and abduction on how machines think. It is a very interesting topic, but before starting to talk about this educational topic of today, let me tell you a little bit about our project. I'm the founder of the Decentralized Web project, and we're building a decentralized communication and advertising platform. Decentralization, most of the times, people when we say decentralization, people think of blockchain technology. As a technology developer and as the founder of this decentralization project, I can tell you that this is very, very wrong. Decentralization cannot be achieved through blockchain technology. The technology has lots of flaws and issues, and it is not next generation of internet, it is not Web3 or Web5. Decentralization can be achieved, in our opinion, as a technology developer, as in a way of direct communication from user to user without going through a server. This, in our opinion, is the essence of decentralization. In our project, we still have a blockchain instance, but it plays a support role just for keeping a record of the incentives, and basically we can define the blockchain technology as a glorified log file which creates virtual value, but the decentralization is done outside of this and beyond blockchain technology. Successful project depends on marketing, and we have been doing extensive marketing by posting on social networks. The list of social networks is very, very long. It includes Instagram, Facebook, Twitter, Telegram, LinkedIn, Pinterest, Reddit, Discord, and TikTok. From this very, very long list, we're focusing mainly on Instagram, Twitter, and Telegram. We're aiming to build a community, and we're inviting you to come join our community, and you can find the lists of the social networks that we're posting on our website, which for the Decentralized Web project is decentralizedweb.org. Decentralized and web, these are two words, but they're all together. Decentralizedweb.org. On the bottom of every page, you can see the icons of the social networks that we're posting on, and you can click on one or more, become a follower, or become a member of the group and the community. Then you can get notified about events, just like the event today, and today is Sunday. We have educational event, and it is happening on the channel of Instagram Live, which is a video and audio channel. But we have a similar educational event on the same topic in the week it is happening, but the day on which it is happening is Saturday, and it is happening on Twitter Space, which is audio only channel. So we have these recurring weekly events week after week, and like these educational events, they started about 1 year and about 3 months, 1 year and 3 months. The topic of our very first event was what is blockchain, and it happened only on Twitter Space. The topic of our second event, which happened on both Twitter Space and Instagram Live the following week, was what is a smart contract. Some of the topics of events which happened week after week were applying astrology into cryptocurrency trading, central bank digital currency versus ordinary crypto, confrontation is looming, big crashes in crypto, Terra, Luna, Celsius, and FTX. Decentralization engines, blockchains as decentralization engine and other decentralization engine implementations. Essence of decentralization, direct communications and ways to achieve it. In the end of 2022, we had 2022 review in crypto. In the beginning of 2023, we had 2000 predictions for crypto in 2023. In the beginning of 2024, we had review 2022 review for the Decentralized Web project and what we plan to have in 2024 for our project. We had several events on artificial intelligence. For example, current state of artificial intelligence and the drive towards artificial general intelligence. We had also an event does do blockchains needs artificial intelligence or vice versa. We have several marketing events and so like for example bending the wheel of the market which was talking about our project and etc. So I mentioned our recurring weekly events which are happening on Saturdays on Twitter Space and Sundays on Instagram Live, but we have a recurring weekly event which is happening also on Thursdays. One Thursday we have general Ask Meeting session, and the following Thursday we have a session which is focused specifically on NFTs. But why? Why do we have a session focused on NFTs? We have Ask Meeting session about NFTs because we did release recently a marketplace and our first collection of NFTs, and it is based specifically on three-dimensional objects. With three-dimensional objects, there has to be a special software which loads and then displays the three-dimensional object. Usually, there are like people who are building, creating, and offering 3D objects. They usually use one of two very popular game engines. They use either a game engine called Unreal or they use game engine called Unity. But like using of this game engines for 3D objects comes with things attached, and that's why we decided to our own software engine, and this engine it what it does like this engine this software engine has this engine optimizes and checks the number of items specific user gets. Then it allows this assistive this asset and displays images of this asset in a browser tab. Then the user can click on one of these images entities that what our screen and the dimensional object in a random fashion, like moving it around the screen. Our 3D software engine also brings lots of capabilities for our 3D NFTs, and the first and special capability for our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak in a male voice or in a female voice or in a whisper voice. In addition to the like normal speed voice, or they can speak in a fast speed voice, or they can speak in a slow speed voice. In addition to them, like if we take a male voice and it is spoken in a slow speed, then this voice can come as the voice of a very masculine person, or it can come as the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed, then this voice can come as the voice of a little girl or the voice of a funny person. The next capability which our 3D NFT software engine brings is the capability of voice recognition. Like our 3D NFTs, like if they load and they're animated in a fashion around them, around the window on a computer screen, you can issue a command to this randomly moving NFTs to stop moving, and then the 3D NFT is going to stand still and stop moving. Then you can issue voice commands to move left, move right, move up, move down, zoom in, zoom out, and rotate. And the 3D NFT is going to fulfill the voice command and move left, right, up, down, come closer, zoom in, or go farther away, zoom out, or start rotating. So that's it regarding the voice recognition capability. And the next capability for our 3D NFTs is the capability of having basic artificial intelligence capability. Wow, really wow. The 3D NFTs can you can ask the 3D NFT what is your name, and the 3D NFTs can respond with their name. You can ask the 3D NFT to describe something, and the 3D NFT is going to tell you in a few sentences about something you want to get described. For example, it can describe decentralization, or describe Web3, or describe the country called Russia. You can ask the 3D NFT, who are you? And the 3D NFT is going to reply in a few sentences who they are. The last capability which we will be having for our 3D NFTs is the capability of seeing this 3D NFT in real 3 dimensions. Currently, the 3D NFTs are projected and displayed in a flat 2-dimensional computer screen, and we are using our imagination to see this like projected 2D image in real 3 dimensions. But we plan to have a second version of our 3D NFTs, and this second version is going to be projected in a way of stereoscopics. What stereoscopics means is that part of the 3D object is going to be displayed in red or reddish color, and another part of the 3D NFT is going to be displayed in blue or bluish color. Then you, the user, can go to our website and order special glasses, and when you receive the special glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can put these glasses on, and when you request the 3D NFT to be projected in a way of stereoscopics together with these glasses, you are going to see this 3D NFT in real 3 dimensions coming out of the screen, and seeing it in real 3 dimensions. So that's the last capability, and so far I did talk about our 3D NFTs and our 3D software engine. But we have also our marketplace, which is unique and special. If we're looking at ordinary NFT marketplaces, most often they are oriented towards having collections of 2-dimensional images based on JPEG or PNG images, and these images are flat and static. In our 3D NFT marketplace, we are oriented specifically towards 3-dimensional objects, and these 3-dimensional objects, they have a list of additional capabilities. As I described, speaking, recognizing voice command, having basic artificial intelligence, and version in stereoscopics. As I mentioned previously, we have our own blockchain instance, and this blockchain instance is used for deployment of smart contracts, which are the non-fungible tokens in our collections. So in this way, we do not charge and we do not require our users to pay gas fees for deployment of smart contracts and gas fees for transfers of ownership from one user to another user. We're detaching the collection from a specific blockchain, and in this way we allow users, when they come to our 3D NFT marketplace, to use several different crypto coins for buying and then for selling of the 3D NFTs. Currently we have a choice of 4 different crypto coins which our users can use for purchases on 3D NFTs on our marketplace. The choice of coins includes Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin KCS. In addition to using crypto coins for buying and then selling of 3D NFTs, the user can use directly fiat currency. So we have a choice of multiple currencies, the fiat currencies of multiple countries, and the choices include like US dollars, Canadian dollars, euros, UK pounds, Japanese yens, Hong Kong dollars, and several other fiat currencies. At the point of registration, you are going to be prompted to choose between choosing fiat currencies and like if the country you are resident or citizen, it's in the list of countries which are allowed to handle transactions in fiat currencies with their currencies. Then you're going to be prompted to enter information for making payments, your debit and credit card, and receiving payments in your bank account. So both buying and selling, they're done directly with fiat currency without going to cryptocurrency. So that's it regarding to the our offer for 3D NFTs. But let's go back to the topic of today. And before going to the topic of today, I'd like to invite you to come to our 3D NFT marketplace and check our collection. And if you like the objects in the collection, you're welcome to buy one or more of these 3D NFTs. The website and the URL of our marketplace is 3dnft.decentralizedweb.org. Once again, it is 3dnft.decentralizedweb.org. But with this said, let's come back to the topic of today, and the topic is induction, deduction, and abduction, on how the machines think. This is topic which relates to machine learning and artificial intelligence, and this educational event was inspired by an article which I did read, and I find this article very, very interesting. The article starts with quoting of a Western philosopher called Descartes, and he had an expression called in Latin dictum cogito ergo sum, and in translation it means I think, therefore I am. This philosopher, which is relatively modern Western philosopher, together with the ancient philosopher which we mentioned in our previous presentation, like most notably Aristotle in ancient Greece. This Western philosopher, they defined for centuries the ideas and thinking behind being a human. They defined it thinking as the essence of being a human. But if like in the present day we want to make thinking, we want to add the quality of thinking to our creations of artificial intelligence, then we have to find the way we do think. Basically, we have to look at the ways of we think, and essentially to think is to reason, and thinking is a complex construct that comes to represent many different things. But for the simplicity's sake, let's assume that thinking more or less it is synonymous with reasoning. And reasoning is a much better defined concept, which increasingly it is used in the realm of artificial intelligence and creation of future machines which could reason, and they could think. So if we ask ourselves the question, can artificial intelligence think? The short answer is yes. Essentially, artificial intelligence can reason, and the reasoning is done in several different ways. Generally, there are three main types of reasoning that we employ when thinking. And these three different ways are deduction, induction, and abduction. Simply put, deduction is the capability to reach a conclusion from a given rule and a case that we assume to be true. For example, we can take the example of water, like a pot of water which is put on a stove, and we turn on the heating of the stove, and then the temperature starts increasing, and the stove starts heating the pot with water. And at some point, like the water in the pot starts boiling, and so going into analyzing the way of deduction. Like first we have the rule that like the water boils when it reaches 100 degrees Celsius. In our experiment, we put a thermometer inside of the pot, and this thermometer is measuring the temperature. But we have the rule of like water starting to boil when it reaches 100 degrees, and we have the case of the water which starts to boil. Then we can safely look at the result, which is a result reached in the way of deduction. And the result is that like the water in the pan is boiling, and temperature is 100 degrees Celsius. So the sequence of like our reasoning is we are going from the rule and case towards to reach the result, which is the conclusion. So like this is deduction. If we look at deduction, it is a fundamental in our ability to do science. So it is also the type of like reasoning and thinking which is the easiest to reproduce in a machine. By design, almost every machine carries some form of deduction, and we can bring the example of calculator where like you put one number and the other number, and then you can have like addition, subtraction, multiplication, division, and doing multiple different formulas, mathematical formulas with this calculator. Basically, this calculator is preloaded with specific rules, and these rules allow it to do the different ways of mathematics that I mentioned: addition, subtraction, multiplication, division, and etc. Because it is specifically oriented towards this type of deduction. So then we can look at induction, and induction is our ability to generalize rules from a given set of observation. Induction is central for our ability to do science, and allows us to quantitatively identify new patterns and new rules. Basically, science is working in a way of analyzing the present nature and analyzing in a multiple different ways, and then making some deduction, um, making some induction based on like based on what we observe and based on the number of experiments that we're doing. We can bring back the case of boiling water, and so we are first looking to the result, which the water is boiling. So we have the case where we put the thermometer, and it shows 100 degrees Celsius, and then we can deduct we can actually do induction of a rule, which is that the water boils at 100 degrees Celsius. So we are doing we're to reach to this rule that the water boils at 100 degrees Celsius. Most certainly we have to perform multiple experiments of boiling water, and all these experiments they show that the water starts to boil at 100 degrees Celsius, so that we could safely assume that this is the rule for boiling water, and the rule is reached through the way of induction, and in the way of induction the sequence of things is we start with the result and the case, and then we form the rule based on the previous two result and case. Of course, this type of reasoning is not always correct. For example, with boiling water, boiling of water depends on atmospheric pressure. Increasing atmospheric pressure or decreasing atmospheric pressure affects the temperature at which boiling starts. Other thing is, for example, if something happens 10,000 times, it doesn't mean that it will always be correct. But safely we could assume that we could form a rule based on our multiple observations in the way of deduction, in a way of induction. And if we're looking at both deduction and induction, they're actually the bedrock of science, and these are both ways which machine learning and artificial intelligence models, they extensively employ both these ways of reasoning. So what machine learning models do is they first utilize inductive reasoning to generate rules from a different data set. Then they apply these rules to new cases in a way of deduction based on the like rules that they did generate. For example, like if we look at the example of model which we present with previously unseen photo, then the model leverages its rules to deduce specific result. For example, if the photo is upside down or in the correct way. And the water boiling example can serve as a simple illustration on why relying solely on deduction and induction cannot quite cut it. We need to generate rule that the water boils at 100 degrees Celsius and then falsify it in a diverse set of cases. However, analyzing false and true cases and deducting a rule that water boils at 100 degrees Celsius, this combination falls short in explaining our guess that the result of boiling have some relation with temperature. So we humans could make this connection, but the machine would have trouble making this connection of water and temperature. So this is why we have to come and see what abduction does. And abduction is our ability to generate new hypotheses based from a single surprising observation, which is currently labeled in our examples as a result. And we do this every time we rely on our own experience to come to one explanation of sorts. For example, we go out and we see a wet street, and we could explain it away with our guess that in the night it has rained, and that's why the street is wet. And we did this in the way of abduction based on our previous experience. We don't need to see 10,000 wet streets so that we could then make a model which does the guess whether the street is dry or wet. We did reach this conclusion based on our previous experience without going through 10,000 experiments with wet streets. So in this way, the sequence of we have the result, which is if we bring back the example of boiling water, we start with the result that the water is boiling. We have the rule that water boils at 100 degrees Celsius, and then we have the case of the we could make we have the case that the temperature in the water must be 100 degrees Celsius, and this way of reasoning and thinking, it was reached through the way of abduction, and the sequence in abduction is we start with the result and rule, and then we're looking at the case, and we see the case there is true based in the way of abduction. So abduction actually is the least reliable of the reasoning types. Chances are that hypotheses that we're reaching based on abduction are not correct. For instance, the result of wet street could be because of a truck did come shortly before we came to the wet street and did spray the wet street with water. So the wet street could have been based on the this truck which did spray water, and then our hypothesis that previous night it must have been rained is not correct. But abduction is a quick and easy way of making reasoning and thinking, and it saves us going through multiple different ways of observation so that we reach specific we make an induction of a specific rule, and then we can use this rule for in a way of deduction to guess whether the street is wet. So so far this way of reasoning called abduction is elusive for the artificial intelligence models, and it is still difficult to find models which do reliably abduction based on their way of way of operation. So currently we have basically assumption that abduction relates to inference to the best explanation, or IBE, or we can say in the best explanation. So we somehow mistake abduction for this in best explanation way of thinking. So in general, abduction covers the act of generalizing a novel case where learning can be transferred from one context to another. So that's about abduction. On the other hand, in best experience is a very special type and more context specific form of induction uh, that's which does not necessarily require us to identify patterns quantitatively. Um, we don't need to observe a pattern 1,000 times to formulate a rule. Um, the exact ways in which these two ways of reasoning are different, it is like complicated philosophical discussion, but for the purposes of the post, it will help to think about them within the rule, case, and result structures and use specific examples. So, for example, some of the uh, expert systems, which were like early artificial intelligence creations, they utilized hardwired chaining uh, inference mechanism. So like they had uh, rules and cases, and then they were looking at uh, they had hard results and cases, and then they were defining rules based on this, which rules can explain the situation best. But these expert systems did not reach wide use, and they had lots of flaws and issues in their reasoning. So basically we are looking at two different things, and we're looking at why abduction and deduction could be elusive, and we have two things: conflation, and conflation means that deduction and abduction are not the same, and we also have the architecture, and the architecture is contemporary and current machine learning models. They are bound by induction, and they have to go through many data sets labeled like positive and negative, so that they could make the rules, and then do a good guess and do a good deduction. So induction bias is integral part of machine learning models, and it is flow of the models, and it cannot make the models performing yet in the way the thinking humans do. So what do we need to do currently? So we saw that machines can indeed reason, and they can do both deduction and induction, but what we label with intuitively as thinking is actually facilitated by abduction, which and the abduction currently continues to be elusive due to the conflation and architecture that we do briefly previously described. So what we do need to do actually? How do we go about building something that can perform abductive reasoning? So first we need to be able to properly define what abduction is and describe how it works. Not much work has been done in this regard, especially when it comes to identifying how abduction relates to induction and deduction. How can be put in operations by machines. The only thing which currently machine learning scientists agree is that abduction comes first, and then it has to be followed by induction and deduction. So what actually is abduction? It is not a monolithic concept, and so like these are the three main types of thinking, and like the exact function which the exact function which abduction does is like first we we have first the straightforward abduction type, which is explanatory. The one we discuss this so far, and to employ it we start with our observation and rule that is easy to identify. The combination of these two enables us to make conjecture about the case. So this is well illustrated in the waterboarding experiment. Then we have like a way of abduction which is innovative abduction. This type of abduction allows us to reason from desired result to a pair of case and rule. We only know what the result we want to create, and then we need to gradually define case and rules pairing, which will allow us to achieve this result. This type of abduction is usually used to generate novel ideas. And finally, we have the third type of abduction, and this type of abduction is the most interesting type of abduction, called manipulative. We use it in situations where we only have a part of the result, either a desired result or observable result. Furthermore, the context in which this result lies defined with multiple and hidden interdependency. So it is not possible to start looking for generalizing a suitable case rule pair right away. Instead, we need to better understand the result and how it relates to its environment and its context. In this third way, we have like lots of uncertainty, and we need to reduce the level of uncertainty. So this is where so-called thinking thinking so-called motivate mediator comes in. For example, in like we have like two different things, and in the middle of them there is a mediator which is looking to both the first and the second thing, and then it goes back and forth, and it generates a thing which is mutually acceptable between the different things. So this is the case in like the most interesting case with partial information, hidden interdependency, and like in this case we need to employ some form of negotiation, going back and forth between the diverse things, so that we could make some form of abduction and like have thinking and analysis of the situation. With this said, I will be ending our presentation. Thank you for coming. Thank you for viewing this event. And I'd like to invite you to come and join our communities. And I can give you the URL of our 3D NFT marketplace, and on the bottom of every page you can see the icons of the social networks that we're posting on, and the URL and the website is 3dnft.decentralizedweb.org. Once again, it is 3dnft.decentralizedweb.org. Thank you for coming. Have a nice day. Have a nice evening, and goodbye.